All right, so let's start our lesson now. This is an interesting topic. To me, it's interesting, right? Because I like chemistry a lot. I'm a chemistry major. Yeah, so this is fantastic for me. When I saw this topic, oh, love it. Okay, so what do you need to know for this chapter? Okay, basically, you're going to find out what is inside the matter. Something we don't see with our naked eye. Okay, in fact, all these are written by scientists. Okay, we are just assuming that it really looked like this. Okay, but it might not. Can? Hold on, I let one student come in first. Yeah, so basically we call these the particulate model of matter. So particulate already tells you it's about particles. Okay, Jinlei is here. Okay, so we are studying about the different particles inside the various matter, solid, liquid, and gas. So you need to show awareness that matter is made out of small, discrete particles that are in constant and random motion. Okay, so it's always moving on its own. Okay, vibrating or maybe, just floating around. Okay, bumping into each other. Okay, they are always moving. You also need to show understanding that the arrangement, okay, and the movement of particles can be influenced by different factors. Okay, and then explain melting and boiling in terms of conversion of states. That means when solid turn to liquid, then liquid turn to gas, right? So all these involve the particle movement. In the past, you don't talk about particle movement so much, but I'm sure in primary school, your teacher mentioned something to you. How many of you learn about how particles are arranged in primary school? By right, you're not supposed to learn all that, but if your teacher has taught you that, it's good because it's easier for you to understand why it happened in certain ways. How come solid can melt into liquid and then liquid can actually turn into a gas? And of course, it can go the reverse way. Right? And then lastly, compare characteristics of the three states of matter in terms of arrangement and movement. So characteristics of three states of matter, you learn in primary school. For example, solids have fixed shape. Okay, but you don't explain why is it that they have fixed shape. Okay, in secondary one, sorry, Zishan?
Like, those like slime substance, like, are they counted as liquid or solid?
Slime, it takes the shape of containers is put in, right? Correct or not? So what do you think?
Liquid.
So it's a liquid. It's classified as a liquid.
What about clay?
What about clay? Yeah, it depends on your clay. If it's dried up, then it becomes a solid, right? Yeah. So clay is not so clear cut. It's like a semi-solid kind of thing.
There's this type of clay that actually is that it never dries up. The special
plasticine in that.
No, it's like they claim that it's clay on the box. Just say it never dries.
Okay. The recent invention not too many years back. Yeah, I know what you mean. It's for people to de-stress. Okay. Again, then I'll ask you, all right, that kind of clay that you're talking about, does it take the shape of the container? Does it change shape easily? Or once it forms a certain shape, it can never be changed. So whenever you want to decide whether it's solid, liquid, or gas, ask yourself these questions. Can, Zishan, but it's good that you're asking, good that you're thinking. Okay. So when you ask me a question, I don't tell you the answer, right? I ask you a question back. So you think even more. Yeah. Okay. Now, so when we look at this particulate model of matter, it suggests that matter made up of small, discrete particles, and then they are in constant random motion. When they ask you what is the particulate model of matter about, it is asked on, I tell you, you will have to write it in this way. Or MCQ, you need to choose, okay, the option that talks about the small, discrete particles and that they are always in constant random motion. Can? Always so. Then Unlock.
Why are they always in random motion?
Because they possess energy. Okay, they always have the energy inside them. Okay, so they are constantly moving. If they are not moving, for example, like those solid particles, they are not moving, right? Is because they are being tied down. Why tied down? Later you will see. Okay, there are forces of attraction that's actually holding them in a fixed position. Okay, so we use models to explain, right, these metals. Okay, so be it solid, be it liquid, be it gas. Why are they like this? We must make use of models to describe them. This represents solid. Do you see the way it's drawn? Okay, it shows that they are vibrating all the time. It's because they possess energy. Okay, so they are always, moving. When they can't move freely, okay, even though they are being kept in place in this manner, they are still vibrating. Yeah, so they don't just stay still and not move at all. Then this is how the liquid particles look like. They don't have a fixed position, but they are still very close to each other. Okay, they can move around each other, right? But they cannot move freely. What's the meaning of move freely? Look at this. Okay, this shows you gas particles.
Miss Tay, look at what?
Mm-hmm.
What are we supposed to look at? My screen is like frozen.
How many of your screens are frozen?
At this page.
Really?
I'm at that page.
I'm already at a different slide. My goodness, poor thing you. Hey, thank you for telling me. Otherwise,
I thought you were loading the page.
I'm already at let me show you where I'm at. Can you all see my page now? I'm actually at this page.
Yes.
Okay. So I was talking about how the solid, okay, never mind. I don't need to go backwards. So, okay. So I was telling you about how the particles in solid are being kept in their positions, right? But because they have a lot of energy, but they can't move about freely. So they just vibrate within their fixed position. Okay. So just now when I was asking y'all about the vibration, y'all can't see a thing. Yes, unlock.
If they vibrate, does it mean that if we leave an object somewhere after a super long time, it'll eventually like move a bit?
No, not that much not that kind of movement, unlock. It'll be scary, It'll be scary to see that, the object actually move on its own, all right, after a long time. Okay, if that happens, it has got to do with like an earthquake kind of thing, then it will be that drastic. Otherwise, these particles cannot be seen by our naked eye. Remember, they are so tiny. Okay, it's like the building blocks of any object we are talking about. It's very tiny. You can't see at all. All right, not even with a microscope.
Are these particles atoms? Just asking.
It can be atoms, it can be molecules, it can even be electrons, or shouldn't use electrons. Okay, skip that. It can also be ions. Ion sounds better. Okay, so it can be atoms, molecules, or even ions. Right? That's why we just put a very general term, particles. Okay. Some books, they are not so accurate. They'll just tell you atoms or they'll just tell you molecules, but that will confuse a lot of things. Okay, for example, I'm just using these red little balls to represent water molecules here. Can y'all see? Okay, so one little red ball is actually water molecule, but does water molecule look like this? It doesn't. Okay, water molecules, if you want me to be very exact, I'll tell you how it looks like. It has a Mickey Mouse shape. Okay, so you want to be very accurate. Then you will be seeing all these Mickey Mouse thing floating around. Okay.
The 2 hydrogen and 1 oxygen.
Yes. All right. And then there's a reason why it has the 2 years there with, representing the hydrogen. Because hydrogen, if you learn more about chemistry, if you learn about electron arrangement, hydrogen has only 1 electron shell, so it's smaller. Okay, but oxygen has 2 electron shells, that's why it's bigger. Don't worry, if you don't understand, you will learn more about this in Sec 3. Okay, so this is actually the very exact shape, okay, of water molecules. But they are now represented by atoms. Shouldn't say atoms, particles, sorry. Now, I have another gas, which is helium, okay? Helium will then be really looking like these red balls because helium is a single atom gas. Hydrogen will be diatomic molecule. So if you want to look at hydrogen, it will be like this. Okay, you understand? Remember we talked about the elements, mixtures, and compounds. Remember we have the MCQ question where they gave you the box, then they have some drawings there. Okay, something like that. Then like this, then they ask you, okay, what is actually this diagram that is being represented? Then you tell me that it's a mixture of a compound and an element. Agree or not? So we were talking about this, remember? So now you understand. Now you don't see any of this yet. Okay? You only see everything as round balls, right? Spherical balls. So you just need to imagine everything now is just in terms of particles, a very general representation. When we go deep down into the substances with the names, we will have to determine whether they are atoms or they are molecules. Clear? So at this moment, no need. Right, hold on, somebody type. Oh, Sheena. Right. Oh, okay. Is that right, Sheena? What lesson was that? Huh? You can type in, let me see. Okay, I'll go and find out about this. I didn't know about that. Okay. Yeah. No, I can't hear you. You're actually muted. So you have to type into the chat. Okay, she gave me some comments, so I wanted to clarify. Okay. Okay, Sheena, you type in now. I'll wait for your response. Okay, now, so let's go on. This part here is about the states of matter, whether they are solid state, liquid state, or gaseous state. Now, you already learned about how solids have fixed shape. Okay, but why is it that they have a fixed shape? You have not learned this part. Okay, so if you take a look, the particles here in a solid, they are arranged in a regular pattern. You might want to copy this down, but it's inside your textbook anyway. Okay, you will see words like this. Orderly manner. All right. Then you will also see things like they have very little, or shall I say, almost negligible, kind of space between them to move. Okay, they are so packed already. Okay, they are so packed already, they can't move at all. That's why no matter how you try to compress it, it cannot be compressed. Okay, you try to pull it apart, it's not that easy to pull it apart due to the strong attractive forces. They stay in their fixed shape. All right, so they have a definite shape, definite volume. What kind of question will come up for such a state here? Let me see. If they were to ask you, probably they will say, can you explain in terms of particulate model of matter?